Let's finish up our talk on the inverse trigonometric functions by presenting a couple of interesting looking problems right here of a typical kind that you will run into in the textbook. In A, we're asked to find the tangent of the inverse sine of 1/4. Now, 1/4 is not one of the ratios that we remember from our basic angles. So you might ask yourself, well, what gives? Well, in this case, what we have to do is we have to think from inside to outside. And you'll recall that essentially what happens is that we're saying that there might be some angle theta. There might be some angle theta whose sine is 1/4. And so we ask, well, what does that mean? If the inverse sine of 1/4 equals some angle theta, then that requires that the sine of that angle theta is equal to 1/4. And if you remember, because inverse sine is limited to angles that start at pi over 2 and go to negative pi over 2, and we're only going to be in the first and fourth quadrants, then we have to draw a right triangle here in the first quadrant whose ratio of opposite to hypotenuse is 1/4. So there's some angle theta here that makes that true. Well, what do we do? Well, use our Pythagorean theorem. The Pythagorean theorem says that if we take the square of 4 and subtract from it the square of the opposite side 1, we're going to get the square of the adjacent side x. Well, that's 15. And since we're in the first quadrant, going off to the right, that means we're talking about the positive square root of 15 for our adjacent side x. Well, how does this help us? In this case, what we're thinking is that, well, when we say take the tangent of the inverse tangent, in fact, we are asking you to take the tangent of that angle. And you'd ask, well, what is the tangent of that angle? Well, the tangent is the opposite over the hypotenuse. So in fact, we're taking the tangent of the angle whose sine is 1/4, and that would be 1 over the square root of 15, or if we rationalize, we would say that's the square root of 15 over 15. Now, don't let this confuse you. Even though we've got a composition of two different kinds of functions all together right here, what we're saying is that, well, we're just finding the sine, tangent, or cosine of whatever the given angle is, where that angle happens to be given in inverse trigonometric form. Well, let's try the next one. It says, find the cosine of the inverse tangent of negative 12/5. So again, we think about our angles right here. We say, well, there must be some angle theta whose tangent will be negative 12/5. So again, we think about where can we put this angle theta. The angle theta can only go in the fourth or the first quadrants, just like sine, because we're limited to angles from negative pi over 2 to positive pi over 2, not including those endpoints. And because we have a tangent, it has to be, since we've got a negative value right here, right, we're saying that there's a tangent of that angle theta that is equal to negative 12 over 5, which implies that if we draw our angle here in the fourth quadrant somewhere in such a way that it contains that angle theta, we know that it would have an opposite to adjacent side ratio of negative 12 to positive 5, which puts it here in the fourth quadrant. So what does that make our hypotenuse? Well, in this case, if we take 5 squared and add negative 12 squared, we're going to get our hypotenuse squared, and we know that that is 25 and 144, which happens to be 169, which oddly enough is the square of 13. And that's good for us, because now we can work this out and say, well, if this is 13, then we're taking the cosine of that angle theta, and the cosine of that angle theta happens to be 5 to 13, adjacent over hypotenuse. So the cosine of the inverse tangent of negative 12/5 is 5/13, and that's the value we're looking for here. Okay, one more here. Let's try this one out. This time we're asked to find the sine of the inverse cosine of negative 7/25. Now remember, be careful here. There's some angle theta whose cosine will be negative 7/25. That's what we're telling you, negative 7/25. And so we think, okay, where could we possibly put this angle? Well, remember that cosine is an angle that must be placed somewhere between 0 and pi in order to obtain a negative. And our negative in this case means that we're in the second quadrant. And so we would draw our right triangle here in the second quadrant and indicate that the adjacent side is negative 7 and that the hypotenuse is 25. And our job, of course, is to find the missing side. In this case, that's going to be our y side right here. So we're trying to find the ratio for sine right here, which means really what we're asked to do is just to find the missing side of that triangle. So let's see. That means that we are going to take the square of 25, you subtract from that the square of 7, and that's going to give us the square of our missing y side of this right triangle. Well, that means we're going to take 625 and subtract 49 from it to get the square of our y side. And of course, this is going to be 576 when we work that out. 576 happens to be the square of 24. Now, it might take you a little while to figure that one out if you're not used to these numbers. But in this case, 24 is our missing side. And so if we're asked to find the sine of that self-same angle theta here that resides in the second quadrant, the sine of that angle theta would be equal to 24/25, and therefore the answer to our question, the sine, evaluating the sine of the inverse cosine of negative 7/25, would be the ratio 24/25. And that's it. That's all we're being asked to do here. Okay, good luck in your assignments. See you in class.